All set? Oh, great. Hi, everyone. Thanks for coming to our talk. So my name is Eric Dubé. I'm actually co-presenting this with Todd Sanders. And what we're going to do today is we're going to talk about an application or a project that we've been working on for quite a while, probably past year, that we think is pretty amazing. I think it's got a lot of applications to it. One of those applications happens to be with the ability to even potentially deploy infrastructure, or at least some of the services. So we want to take you through that today. We're going to give you a little bit of detail about it, tell you about the architecture, and we also want to give you guys a live demo. So this is not something that's pre-recorded. We're actually going to take a chance, take a gamble, and run through this thing. It's a really, really awesome demo, so make sure you stick around for that. So how many of you actually have heard of Kubernetes Service Catalog project? Anyone in the room? A couple of people? Okay, one of the things that's been recently introduced in the Kubernetes community is this notion of a service catalog. And with service catalog, it's a way to present services to consumers or service consumers. One of the things that works in conjunction with the service catalog is a service broker, and that's what exposes the services. And the reason for this introduction, this new introduction of this architecture, is basically because of the traditional model where services, were being ordered. You put a request in a ticketing queue. You'd have to wait for IT to allocate that service. You'd receive some credentials and endpoint. Then you could basically configure your application and then finally deploy. But the amount of time that it took to do that, and also it was an error-prone method. And this is still being done today. But the idea here now is that you can use this new technology, this new service catalog, to be able to reduce the error and speed up the process significantly. And we think it's pretty cool technology. So what is a service broker? A service broker essentially is what exposes services to the service catalog. And I'll show you a picture of what that looks like in a second. Consumers only interact with the service catalog. They actually don't interact with the broker. The broker is hidden for the most part. And the reason why the broker is hidden is that's just operating, doing all the legwork. The front end is really what the consumer is interacting with, right? To order, provision that service. That's essentially how it's working. A couple terms I'm just going to make note of. I'm not going to spend a lot of time here, but consumer is the person who actually interacts with the catalog. A service is something that's exposed in the catalog, an application. Plan is a flavor of it. The idea is you can have, like, for instance, a bronze, silver, and gold tier. So you maybe have no storage in the bronze if you're deploying a database. You might have persistent storage, more memory in the silver, and then et cetera. Gold could be a higher offering. Service instance is actually the deployed service. It's the running instance of that service. Provisioning is where you create or request the creation of that service instance. And then binding is where you will associate two services together. So essentially, you're passing credentials to the application so they can talk together. So here's the service catalog. This is actually the new UI. This is what it looks like from Kubernetes. The idea here, again, it's a better experience for consumers. It streamlines getting started. And what we mean by that is you can have anyone go in. You can assign which services that they can deploy. And then once they have that, they can sit there and order as many of these services as they want based on the permissions they have. So it makes it really, really easy. It's also a central location for all the different services. And the idea with Service Catalog is that you actually can have more than one broker behind the Service Catalog. So it's a one-to-many. So you have one instance of the Service Catalog, and you can order services from many different brokers. And in this case, we're showing here, it's this one available OpenShift template broker. We're the Ansible broker, second one in the list. AWS Service Broker, so the Amazon guys, they're actually working with us. They're using our broker to make their services available. So that's actually kind of a cool project we're working on. And there can also be other services. You could have something, say, on GCE or Azure, or even something local. Create your own broker, okay? How is it done? So brokers utilize this API called the Open Service Broker API. So this is a standard API. It's a multi-vendor backed API. It was a successor to the Cloud Foundry Service Broker API. And what it really does is it defines the interface between the marketplace, which is the service catalog, and the service brokers. So the service brokers is actually what implement the Open Service Broker API. And it's comprised of a number of different operations. It's a REST API. One of those is catalog, and that essentially allows the broker to expose the services to the catalog. Provision, again, create that service instance, deprovision, remove it. Bind is where you want to create credentials to tie services together. Like obviously, unbind is the opposite. And then finally, this new one that just got recently introduced called update. An update essentially is where you want to change an instance, service instance parameters or service plan, like the idea I said earlier about bronze, silver, and gold. So you can go, for instance, from silver to gold or from development to production, right? That would be a good example where you might want to bump up the service plan of that service instance. So why did we start this project? And there's a number of reasons why we did. We really wanted a way to define how you deliver simple to complex applications. And there's not a lot of great technologies out there. There are some others. If you guys maybe know of Helm, even the stuff they've been doing with Helm and Helm OpenStack. But it lacks a lot of abilities that we think we make up for with our implementation. We think it's a lot better. And I'm not trying to badmouth those. I think Helm's a great technology. But it actually offers more, and it's very, very lightweight. The other thing we can do is our application definition is actually a container image. So we can not only ship the definition, but we can also ship the definition, or easily ship the definition. We can ship it with the container binary image. So they can be done in the same image registry. So some of the goals we had is that we had to be able to work with existing applications. So what we mean by that is so say sometimes you have third-party or prepackaged binaries where you can't open them up and manipulate them. No problem. You can create a definition to go deploy that without peeling it open. We want to be able to build a large ecosystem. We've actually already started doing that to make services available for the service catalog, Kubernetes service catalog. And then really we're looking, and this is one of the ways we're looking to grow interest in the community, working with folks like yourself. So the Ansible Broker is comprised of two different components. One's the broker itself, and again, that's what implements the Open Service Broker API. That's what exposes those services to the catalog, and then gets Kubernetes to do all the work, right, to provision those services. Then the other one is something called the Ansible Playbook Bundle. What that is that's the application definition. What we mean by the application definition, how the application gets put down, how a bind credentials get created, things like that. That's actually the definition. I'll explain in a minute what's actually in the definition itself. So here's the architecture. So this is kind of the layout of how everything works. We start with the service consumer is over here, provisions a service from the service catalog. Service catalog then talks to the broker. The broker then gets the container image. And again, these are different APBs. We're just showing some examples here. So Ansible Playbook Bundles. That Playbook Bundle is ran, and then you end up with the service that's been deployed. These are short-lived. They don't live that long, just long enough to be able to start the service, configure it the way you want it, then they go away. So it's really just something that's quick, a quick interface layer to start your applications. One of the things that's neat about this technology is it doesn't just apply to local environments. We can actually manage remote services too. Not just remote services, but also public cloud services. This is actually one of the reasons why the Amazon guys are working with us, because we're able to provision EC2 services. And there's actually a number of services we already have running today. I think it's about 10 services we have. And that list will keep growing. Here's the Playbook Bundle definition. It's actually, again, it's a short-lived container. There's not much to it. It's really just a simple directory structure. There's named playbooks, so if you know about Ansible terms, there's a deployment role with action playbooks. And the playbooks, really all they are is, provision, deprovision, bind, unbind.yaml, right? These are just playbooks that sit in there, and they're really pointing off to a role, an Ansible role that's also included. A little bit of metadata. There's not much in the metadata. It's kind of some config information. And then you have an Ansible runtime. That's just enough to be able to just run a very minimal amount of code, provision that service, and then end, okay? There's really not much to this. We do have tooling available to actually walk you through creating these. It's very, very simple, very easy to use. It doesn't take a lot of knowledge to create these. Todd will actually show you one during the demo. And some of the advantages, and I mentioned some of these already, but I'm going to kind of bring them up again. Again, we can orchestrate both on and off platform services. Again, not just local, like pretty much all the technologies out there. I could be wrong, and if I am, please correct me, but pretty much none of the other technologies out there today can manage off-platform. And that's a big deal, because if you want to be able to tie your public cloud instances into your local environments, that's really where you need a technology to be able to do that. Highly customizable, so you can get very complex bind operations, exchanging credentials. You can actually have complex control logic. So what we mean by that is like if that, then this, versus everything being linear in a template style orchestration layer. And then the other thing we find is really, really cool, and it lacks in pretty much just about all the other technologies, is the ability to wait on dependent services. So say, for instance, you're starting Glance, and then you're waiting on the database to start. Well, if you really look at a lot of the other ones, the downfall is you start the first container image, but really it's not ready yet, and you start the second service, which is dependent upon the first service. Second service fails. And the reason why is it's actually not running and servicing connections yet. So with this, we can actually wait for it. We can actually check to make sure that database is actually functional before starting the dependent service. And that's a big deal. It doesn't sound like a lot, but you see a lot of technologies fail on this. OpenStack integration, that kind of gets us to that. So some of these things, I've already covered, but I'll just go through really quickly. Again, that dependent service startup, we know for a fact OpenStack has a number of these dependencies. And if you look at some of the orchestration technologies out there, they put a Band-Aid around it, right? So they have that simple template form, and then they're like, well, we have some glue around it to wait and do these other operations. You actually wouldn't need it with this. Again, that complex conditional logic, some of those things you can kind of order things or decide on the fly what you want to start based on parameters. The other thing we've actually been engaged with was the OpenStack upstream community. And we were working with them a little bit to do a POC, all based on Ansible. Once that's created in Ansible, creating application definitions or APBs for the OpenStack services is actually really easy. It's not a lot of work for us. And the other thing we want to look to is really kind of, look to folks like yourself for collaboration. If there's anyone who wants to work with us, we'd love to have you contributing. And we do have some community website where people are contributing their own services and applications. And Todd will talk about that later on. So I want to go quickly through the roadmap review. Make sure we get in time here. One of the things that we have, we're doing all the development today is on OpenShift Origin, but we're actually also doing work to make sure it's going to be pure Kubernetes environment supported. That's probably nearly done. Maybe it's already done since I've been here, but that work's been going on. The other thing we want to do is really build out the application ecosystem. We already have a ton of applications out there, but we want to build more. And that includes not only community contributed ones, but also commercial ISVs, right? You know, we look at a lot of things. It's great you can have someone say, hey, well, I stood up this instance of, you know, MongoDB or, you know, MySQL or MariaDB, but it's not supported. And a lot of our customers, we're finding they want supported applications, right? So we want to be able to have both, right? We want the community ones that are free, that any developer can take out, check out and play with. But we also want the commercial ones, right? We want to be able to deploy real services that people can use in production environments. And we've already been working with a lot of ISVs. We have several applications already available today. So the release plan. So today we have 3.6 out in the OpenShift origin. Again, it's going to be working with Kubernetes. So you'll be able to use this in any environment. We just happen to use Origin because it's easy and has all the Kubernetes components under the covers. But it has, again, that new UI, that service catalog, that interface that I showed you earlier. Todd will also show you in the demo. We also have support for the brokers in the Open Service Broker API. 2 brokers are available, again, the template broker and the Ansible broker. We have several APB services that are available with Origin. And the tooling's not there yet, but it can be obtained remotely or outside of Origin. 3.7 is going to change that. We're actually introducing the tooling right out of the box so you can actually start doing development. We're going to have support, put new services in there out of the box. Support multiple service plans. We'll have secure connectivity now, make it really robust from the service catalog to the broker. And then finally, this has really been hardened over the past several months. So we'll be able to support production workloads with it, which we're really happy with. So we're sort of stepping from, you know, an early beta to really sort of more the first GA. So here's what we're planning in the future. We have a lot on our plate. This may look like a small list, but it actually is a pretty large list. Each one of these things are quite a bit of work, but let me go through a couple of them, just kind of give you what we're thinking about. Really want to look at adding better support for the update. We're thinking that might even be able to update versions of instances. You know, so you had, say you have, you know, my PostgreSQL 9.4 and you want to go to 9.5, right? So we're even thinking about that and ways that you can basically keep that database intact, right? Do it gracefully so you don't lose any data, and then get that new version updated. So we're thinking about enhancing that a little bit. Improve broker scaling. So we want to look for larger and bigger environments. For development on a Mac, we're looking at mini-shift, internationalization, localization, additional source adapters. So today we're doing image registries for the application definitions, but we've had some interest to put those definitions other places. One of those is actually Amazon's EC2 container registry. So we're going to look at doing an adapter for that. That's actually underway. I don't know when it's going to be ready, but it's underway. GitHub might even be another option. Better verification of those deploy services, making sure that when we provision something, it's up and running. Even things like custom UI, where we know there's complex applications, complex services. OpenStack's one of those, right? We can be able to have better UI integration with those complex services. Let's see what else I want to say on this one. Yeah, looking at use cases outside of the service catalog. So one of the things I didn't tell you about this technology, and I'll just briefly mention on it, we use Ansible today inside the application definition, inside that container image. Technically, we could use something else. That just happens to be the runtime. There's the entry points for Ansible to run, but there's other things we can do with it. And one of the things we love to hear from folks is what other applications would they like to see it do. Our broker's pretty robust. It's easy to scale on services and it has a lot of control when used with the service catalog. but it doesn't necessarily have to be the only way you interface it. We do have a CLI that you can actually go in and run things. It's not quite set up for, I would say, a great experience in the CLI, but it's there. It's something that we could improve. But until we know what those use cases are, it's kind of hard for us to kind of come up with something better. But if there are other applications that you guys think you'd want to use, let me know, and we will make it work. The other thing I want to mention here is, let's see what else. Split runtime. That's actually an interesting one. Reason for that, we were looking at that, is where you can decouple the Linux image from the content. And the reason why you want to do that, maybe you want to have different Linuxes, maybe you want to be able to seamlessly update all your instances, whether it's CVEs, bug fixes, security issues, or you want to manage and maintain it separately. The idea that would actually mount on the fly all the content, 2 container images, one mounts inside the other one, and you can basically run that content. So that's kind of a neat thing. The last 2 on this list, async bind, this is actually underway. This needs to be fixed in the upstream API. This is kind of a little bit of a problem for us right now. And the last one is the test operation. We mentioned it earlier, I didn't really cover it, but we've had a lot of interest to extend the Open Service Broker API to support something as a functional test. The reason for that is, it may not be apparent, but for instance, you have a certain version of your environment, you deploy all your services, you know everything works great, okay? Now you roll your update your environment. How do you easily test all your services? And you could have hundreds of services. So the idea behind this is you can create a functional test with the test.yaml, another playbook, and then actually have the broker run through each of the tests, get that result back, make sure it provisions, make sure it's actually active, running connections, and it allows you to have self-testing applications. That's a huge deal, right? To be able to set up a CI/CD environment, that's actually something that you would really need in that environment. So that's something we're going to put a little more work into. It's not part of the spec today, but you can actually run these directly from the broker if you need to. With that, I'm going to turn it over to Todd.
All right, thanks, Eric. We're going to try to go through this fairly quickly because I think we're a little short on time. Basically, what I wanted to show you is a couple things live, as Eric talked about. So I want to show you sort of finding a service, provisioning it, actually binding 2 services together, connecting to an external SaaS provider for a service, and then actually updating a service instance. The little sample application that we have here to actually go through this demo is essentially just a 3-tier web app with a database, an API layer, and then a web-based front end, a Django app-based front end. What we've sort of done here is we've taken the back end, the API layer and the database, we've modeled that as a single APB, or Ansible Playbook Bundle, essentially an application definition for those 2 layers. So when that APB spins up, it's actually going to deploy 2 pods. It's going to deploy the database, it's going to wait for the database to come up, it's going to seed the database with data, and it's going to bring that API layer up. And then there's a second APB for the front end, which is essentially just going to bring that Django app up. We're going to do a bind. We're going to tie those 2 together. So we're going to pull the credentials for the API. We're going to inject those into the front end. And then voila, we'll see that the front end is actually talking to the database. We're going to do a little bit of a twist if we have time. We're going to unbind from that internally deployed back end, and we're now going to bind it to an external off-cluster SaaS-provided back end. So a separate API that I want to take my front end, which will be running in Kubernetes, and tie into the cloud for a separate API to provide data. So with that, we'll jump over and we'll go through this quickly. So first thing is I'm going to log in here. And what you're seeing here is actually the Origin service catalog. I'm going to quickly, just to make this a little easier to see, I'm going to go ahead and just filter on APB, and you're going to see that we have sort of 3 APBs up here that I talked about. So this internal dog API APB is the backend for the internal backend that we're going to run on cluster, and then the random images APB is the front end. So the very first thing I'm going to do here is just create a project that I can run this in, a separate namespace. So we'll create that. And then we're going to go ahead and we're going to provision this back end internally on our cluster. So I'm going to go ahead and choose this service. And what actually shows up in this sort of configuration UI is really dictated by how the APB author wanted it created. So for example, Eric mentioned the idea of service plans. These service plans are actually surfaced in the APB. So the author for this particular APB decided that they wanted to have a development plan and a production plan. Some APBs only have one plan, they call it a default. You'll skip this step. Some may have multiple plans here. And again, these plans are actually upgradable depending again on what the APB author wants to provide for the service consumer. So we're just going to choose development here. For configuration, we're going to choose that we want to actually provision this into the Summit demo project that we created. And then there's a set of parameters here that, again, are surfaced by the APB author. They're configuration points for what you want to provide to the service consumer to actually configure your service. For these, the API key and the API secret, I'm just going to leave those blank so they're automatically generated. And then the database settings down here, database name, user, and password, I'm going to take the defaults here, and we'll move on. Binding step, I'm actually not going to bind right now because I want to do that in a separate step so you can sort of see these things and what the power of that happens. So we're going to go ahead and create here. So that service is actually spawning that APB. So we'll jump over here and we'll take a look at the logs of the APB run. So this is that back-end internal APB. It spins it up. It's actually running Ansible. You can see it here if you look at the last messages there. Now we've spun up the database pod. We're waiting for that to come up and start servicing. And then once that finishes, we'll go ahead and connect over, seed the database and spin up the API layer. While I'm waiting for that quickly, I'll just jump over here to GitHub and show you. This is sort of the back-end APB. So as Eric mentioned, there's an APB YAML. This is really just metadata that's used by the broker. It basically, APB can tell the broker all the attributes of its service, things like the parameters that I want to expose in the UI, whether or not those parameters are updatable for a running service instance, or even plan information. So here you can see the development and the production plans are defined. The rest of this is really just Ansible. So if you look in the playbooks directory, as Eric mentioned, there's a set of playbooks here that correspond to those Open Service Broker actions. And then if you dig into one of these, basically you'll see that in this case it's a very simple playbook that uses a Ansible role underneath the covers. And that role is actually contained in the same tree. So you can go into the roles directory and you can see under tasks under main.yaml, you can see the actual role and the actual execution of sort of what's happening behind the scenes. We do take advantage of a set of Kubernetes Ansible modules that we use to allow us to talk that API to the cluster to be able to stand up these services. And I know that was quick, but trying to save time here. So as we can come back over here, we see that Ansible Playbook Bundle has run and it's exited. So we'll step back over to the Summit demo namespace, and we will see that the API is up. We can actually hit this endpoint here and see that now I've got the database up, I've seeded the database, the API layer is up, I'm hitting it, I'm getting valid REST back, everything looks good. Next step is let's bring up the front end of the application. So we're going to go back to the catalog. We're going to find that random image viewer. We're going to launch that. Again, we're going to check that we want that in the Summit demo namespace. And here it's actually giving us a parameter, an album title. I'm going to go ahead and just name this dogs because that first API we're hitting is actually going to return a bunch of dog images. So we're going to choose that just to name that. We'll go ahead and create that. We'll go back to the Summit demo project. We'll wait for that APB to run. I'm actually not going to switch over there and show you that this time. This should run fairly quickly. But this is just spinning up a Django app and creating the route for it. So we'll wait for that to complete, and then I'll show you that. It should just be a few more seconds here. Okay. So we'll go ahead and hit the demo app this time. Oh, not ready yet.
Not loaded yet.
1 minute. Live demos are fun. Oh, sorry, the deployment's still running. Yeah. Now it's ready. So now you can see, so hey, that's kind of interesting, but my front end is up, but it has no data. My back end is up and it's serving data. So now what I need to do is bind these two together. So I need to take the credentials from the back end API, inject those into the front end, redeploy the front end application, and then we should be good to go. So let's go ahead and do that. So the first step we're going to do is we're going to actually create a binding on the back end service. So we'll click here, we'll create a binding, we'll say bind. This is actually creating a secret in my namespace. And then I'm going to take that secret, and you can actually see here's the API key that was auto-generated, the secret, the connection URL. And what we're going to do is we're going to actually inject those into the running app. So we'll do that. That'll modify the deployment configuration and redeploy that front-end application. We'll go back here, and you'll see that redeployment is running. We're now on deployment number 2. Will give us a second to actually spin these containers up, or respin that container up. When that comes back up, my expectation is we'll refresh that front end URL and we'll actually see data. We'll give this just a second.
You got 9 minutes.
Okay. So we're just waiting for that deployment to come back up. This is actually running in EC2, so it's a little bit slow over the network, but
There you go.
okay. So we'll come back here to the album, we'll refresh this. And there you can see. So now we've taken that front end, we've bound it to the back end, and now we see data coming from that back end that we provisioned. If we have time, what I'll do next is I'll actually break that bind. So I'll unbind. So I'm going to come back down here. I'm going to break that connection. I'm going to choose the little kebab menu here. I'm going to say delete binding. What that's going to do is that's going to delete that secret out of my namespace. And then from there, the other thing that I need to do is I actually need to go remove that configuration from the app itself. So I'll come in here and I'll say I don't want to use that secret again. We'll save that. That effectively is going to redeploy that application, but now I've broken that link between the front end and the back end. The next step would be to go ahead and deploy an APB for the external API that I want to use. So talk to the SaaS provider, create an instance of that, and that's what we're going to do here real quickly. Again, we'll choose Summit Demo next, and we won't bind, and we'll deploy that. So again, this is actually talking to that SaaS-provided API, creating an instance of that back end. That'll happen very quickly here. Okay, that's up. I'm going to actually wait for the deployment of the front-end app to come back up here real quick before I can go ahead and create another binding here. So we'll do this. And this again, I'm creating a secret with the credentials to now the external SaaS-provided API. We'll go ahead and add this to our application. So we've done that. We'll wait for deployment number 4 to run here real quick, and then my expectation is when this comes up, we're now talking from our front-end app that's running in Kubernetes out to a back-end that's running in the cloud, so off cluster. And this, you could think of this as very similar to the integration that we'll have with our EC2 services. So I should be able to come back here to the random album right now. We'll refresh the app, and now you'll see it's a little bit slower, but I'm starting to get cat images in here. So now I've tied up to a completely different separate API. Last thing I'll show you real quick is we talked about updating services, so I want to go ahead and update this service. So I'm going to come in here, I'm going to choose Edit on the Demo app. And this really isn't dogs anymore, so I'm going to go ahead and change the album title to be cats. So again, this is just updating that running service instance. We'll save that. That'll actually go redeploy the app for the 5th time. When this comes back up, we should see we're bound to external SaaS provided cat API, and now we're actually seeing that the album title has been changed.
One thing, if you notice how quickly he's doing this, all right? So there's no magic to this. This is a live demo, but one of the things that's really nice about it is the application definition is handling all that for you. So it makes this a reliable, reproducible way of doing and deploying, it should be a way of deploying those services. And that's pretty important.
It's not very fast.
So we're just waiting for this.
It's not up yet.
There you go.
All right, there we go. So we've updated it. It now says cats. Voila. So that's it for the demo. There's a few extra slides that we want to cover real quickly here, just some additional information.
Use the pointer if you want.
So as Eric mentioned, we are building an ecosystem for these services. So we have a GitHub organization called Ansible Playbook Bundle. There's a number of community-driven Playbook Bundle or services being developed as Playbook Bundles out there. The nice thing about this particular project is we do have CI running for all of these APBs as things are checked in. And we also have automated builds that publish out to a container registry that is by default tied up to the community version of the broker. So as you develop these APBs, you're going to get testing by the community because natively, when you run the broker, you're going to pull in that set of services that's tied to this. There's a number of services that are out there now, and we're continuing to grow this as we go forward.
Yeah, one thing I'd like to say is we'd like to start seeing some of the OpenStack services get contributed in there. So if anyone's interested, like I said, contact us and we'll help you get started.
Demo environment, obviously we want to make this very easy for you to get up and running. Folks are probably familiar maybe with OC Cluster Up. We built sort of a wrapper around that called Cat ASB. You can see that project here, but essentially what it does is it basically very quickly brings up OC Cluster Up. So it brings up your cluster, brings up origin, pulls in the catalog, bootstraps the catalog, bootstraps the broker, ties you up to our container registry so you can get these APBs into the catalog and you can move forward. So what I ran from this demo is actually running Cat ASB. For me, from the time I check that out to the time I actually run it, it takes probably 3 or 4 minutes, and you're actually running the same demo environment that I showed you here today. And then finally, just a little bit about the project. If you want to find out more about it, we do have a public mailing list, an IRC channel. I'd point you at the YouTube channel. There's a number of really, really good demos out there, much more involved than probably what I showed you here today. So I'd encourage you to go take a look at that if you're at all interested, and then sort of some contact points. So with that, I think that's all we have for today. So we'll open it up for questions if there are any.
Sure.
So is this primarily meant for exposing and binding together web applications that are communicating with TCP, or is it sufficient for deploying and managing data management offline services, things that aren't going to be outwardly consumable?
Aren't going to be
Like a daemon service where it's not necessarily directly consumable. I would say this is more the application
Probably
developer side.
Yeah.
Yeah. I would definitely say, I think more of this is probably around, paths, but you got to think about it. It could be any running service, right? Like it could be a database that maybe you're not directly connecting to, but it's relying on some kind of front end service that maybe you are. So I would say less about system services and more about applications. Go ahead. You can keep at it. We'll keep answering them. I don't mind.
Have you guys thought through what work has gone into integrating this with some form of API management, so people can submit a playbook, publish that application, and integrate it?
Well, we haven't. Good question, though. I know we should have an answer since I come from a company who has API management under the belt. No, we haven't. Good question. It's something we probably should take a look at.
What's the current mechanism if we're managing all of our playbooks out of Git right now? Is it still go pull those and send in, do you wire something up through a mashup that's listening to webhooks, or say you're integrating with potentially Git or ECS here?
We haven't done Git yet. Right now, everything's still in a container registry, but you can obviously put all your content in Git, right? So what's happening is that content gets built, right, and then that container image gets pushed to a container registry, and the broker's pointed at the container registry, and that's how it's actually getting access to the APB services.
We're going to have to wait for the update extension to the API to be able to make hot updates?
Hot
Can we
updates.
do this without redeploying over and over and over? Our application supports it.
You'd still need, what he's saying is every time you make a change, but
You gotta redeploy the application.
you have to redeploy the app.
I mean, essentially, you can control, well, you have complete control over what that means, right? So you don't have to redeploy the app. I mean, if you have support for not having to do that, then certainly you can do that. It's just sort of how we've implemented these APBs.
Yeah.
Does that make sense?
Yeah, most of these services, obviously you've probably heard of pets and cattle. I mean, most of the stuff's, cattle. It's not pets, right? So you do a config change, you just start it over again, right? But obviously, if there's something a little bit more intelligent where you don't necessarily want to disrupt it, but you want to make a config change, you have that option.
Yeah, essentially you're firing up something that's giving you an Ansible execution environment, so really anything you can do in Ansible, you can do with this.
And the Ansible runtime is wide open, full?
Yes.
Yeah, it's pretty powerful too. I mean, that's the nice part about it. Is you can do literally anything with it.
So, I mean, you can imagine, hey, I want to spin this up. I want to deploy my app. I need to go open some firewall rules. I mean, you could do anything, as part of this run. Really kind of, the sky's the limit in terms of anything you do in Ansible.
And there's also modules too. The other thing you can point out too is a lot of the work we're doing with Amazon, the APBs themselves have almost nothing in them. It's all because of a CloudFormation template. And there's an Ansible module for that actually interprets that. And that's actually where all the work really is, the legwork. It's not really in the Ansible code itself.
So where is AWS and the tower fitting into all this?
That's one of the things that we're on a list. We really need to do better integration with Galaxy, and obviously you get Tower. And it's something that we've been talking about internally. I think right now it's just sort of we got something out the door. It's not that we don't want to do it. It was sort of like getting the MVP, so minimal viable product, and this is really like the first GA is just about to come out. After that, we can look at how we do the integration story, because there's things in Ansible Tower and Galaxy that I think we're going to need to kind of change the notions, not from a node concept, right, but from a running instance of a service, and that is fundamentally a little different. So I think there's some things that need to change, but I think it's all workable. And then maybe what we can do is we can tie the broker to using the playbooks and roles that are managed within Tower or Galaxy instead of going within a containerized application definition.
Yeah, I think the Tower story is really interesting when we start talking about managing services at scale.
Yeah. Not only that, lifecycle, right? I mean, upgrading other things.
So it's definitely something that we will intersect with in short order.
Can I maybe make a request that whatever the story is going to be around that, we get that out there early, like first before trying to get an MVP. It's extraordinarily confusing trying to figure out where it's safe to invest time, what's has a high velocity of change right now where you're investing.
Yep, makes sense. It's
Yeah,
a good suggestion.
that's fair. All right, well,
we're about out of time, so-
we're a little over, but I can stick around, Todd can stick around if you guys have any more questions you want to come up to us. But anyway, thanks for joining us today, and enjoy the rest of the conference. Thank you.